This is Professor Antonio S. Marahas, and this is Advanced Digital Technique. We have discussed the K-map using the sum of product expression. We go now to product of sum expression. Okay? But we will go directly in a 4-variable map for the sum or the product of sum expression. So we have here again a truth table with an output. Okay? So you want to determine the logical or the simplified logical circuit for this particular output. So again, we make a map. Okay? So again, 16 cells. So you have inputs A, B, C, D. Again, the input values are 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay? Then the values of your cells here. Now this time, since we are using the product of sum expression, we will have to obtain the sum term. Okay? And according to our definition of a sum term, the sum term can be obtained by considering the value of your input. If the value of your input is 0, then the variable is not complemented. Okay? So in this case, you have A is 0, so you have A not complemented. Then B, you have sum term, so you have plus 0, that is B, plus C, plus D. Okay? Can you follow? So this one here, A is 0, so you have A not complemented, plus B is 1, so that's the time that you complement the variable. Then C is 0, so you have C plus D. Okay? Then you have A is 1, so you have A complement plus B complement plus C plus D. Then you have A complement plus B plus C plus D. Then you have A plus B plus C plus D complement. Then you have A plus B complement plus C plus D complement. Okay? Then you have A complement plus B complement plus C plus D complement. Then you have A complement plus B plus C plus D complement. Then you have A plus B plus C complement plus D complement. Then you have A plus B complement plus C complement plus D complement. Then you have A complement plus B complement plus C complement plus D complement. Then you have A complement plus B plus C complement plus D complement. Then you have A plus B plus C complement plus D. Then A plus B complement plus C complement plus D. Then you have A complement plus B complement plus C complement plus D, and then A complement plus B plus C complement plus D. So that would be the value of your cells in the sum term, okay, or the location of your sum terms inside your K-map. Okay, then if you notice that in these 8 adjacent cells, the A here is the common variable, no? So you have A, this one here, and this one. So that means that this area here belongs to A. And this particular area here is where A bar is located. So in other words, this area here is under A bar. And this one here, the common here is B bar. And this area here is B. And then this area here, the common is C bar. Okay? So C bar, and this one here is C. And then here, the middle, what is common here is your D bar. So this one here is D, and this one here is also D. So if you notice that this actually, the location of your variables is actually the opposite of the location of your variables in the sum of product expression. So baligtad sila. Okay? Even if the values of your A, B, and C, D are the same, but then ang iyang location sa imuhang variables are located in the opposite way as that of your sum of product expression. Okay? Then we locate this X here in our map. So we draw here a map. Again. Okay. Then you have A, B, C, D. You have 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Again, this belongs to A. This one here belongs to A bar. And this one here belongs to B bar. Here, B, B. And then this one here belongs to C bar. And then C. And then here, this is D bar, D, and D. Okay, next is to locate the value of X here in our map. So this time, since this is POS, we consider the value of your X equal to 0. So we locate where the zeros are located in your map. Okay? So you have for 0, 0, 0, 0, X is 0. So if 0, 0, 0, 0, the X is 0. So you place a 0, not 1, but 0. Then you have 0, 0, 0, 1. 0, 0, 0, 1. You put 0 instead of 1. And then this one. 0, 1, 0, 0. 0, 1, 0, 0. Another 0 here. And then 0, 1, 0, 1. 0, 1, 0, 1. Another 0. And then 0, 1, 1, 0. 0, 1, 1, 0. Then 0, 1, 1, 1. 0, 1, 1, 1. And then 1, 0, 0, 0. 1 0 0 0, and then this one 1 0 1 0, 1 0 1 0, one, and then 1 1 0 0, 1 1 0 0 here, then 1 1 0 1, we have 1 1 0 1 here, then you have the last one is 1 1 1 1, 1 1 1 1, that will be here. Okay, so that will be so this is 0 instead of 1. Okay, so to review, we have 0 0 0 0, you have 0 1, then 0 0 0 1, 0 0 0 1, then you have 0 1 0 0, 0 1 0 0, then you have 0 1 0 1, 0 1 0 1, then 0 1 1 0, 0 1 1 0, and then 0 1 1 1, 0 1 1 1, and then 1 0 0 0, 1 0 0 0, and then 1 0 1 0, 1 0 1 0, then you have 1 1 0 0, 1 1 0 0, so it should be here. Then 1 1 0 1, 1 1 0 1, this one, and then 1 1 1 1, 1 1 1 1. So this one here is not included. Okay, so it's good to review the location of your output. Okay, the next is to, of course, group the number of cells which are adjacent. Okay, again, the same yapon ang grouping, no? 16, 8, 4, 2, 1. So since there are vacant cells here, so we cannot say that there are 16 cells who are adjacent. But just in case that all of the cells here are 0, we have 16 cells, 0 ang value. That means that x will be equal to 0. Okay? So, if there is no 16 cells, then we go to 8 adjacent cells. So, we find 8 adjacent cells. Naabata? So, wala, no? Wala tayong 8 adjacent cells. So, we go to 4 adjacent cells. Okay? So, we have here 4 adjacent cells. Asa man na? So, first is this one. Square. Okay? Then, this one here. 8 adjacent cells. Okay? Then, what else? This one. 4. In line. Okay? So, the same yapon sa ito ang SOP. Then, again, 4 adjacent cells. This one here. And this one here are adjacent. So, that is another 4 adjacent cells. And what is left is this one. Okay? So, since wala siya pares nga mahimo siyang 4 adjacent cells, we go to 2 adjacent cells. Asa man ang adjacent cells niya? 2 adjacent cells. This one here is adjacent to this one. Why? Again, if you fold this one, going there, just like a paper, for example, then this particular part here and this particular area here will be connected together, and therefore, the 2 cells become adjacent. Okay? So, this cell here is adjacent to this particular cell. Okay? So, if you notice also that this one here are also adjacent. So, but no need to group them because all of these cells here are already grouped. Once you do that, then there is what we call a redundant variable present in your equation. And that will not be a simplified logical equation. So if all of these cells are already grouped, then no need to group, no need to force to group other cells which are not needed. No? So just avoid that one. Okay, so how do we obtain the equation? Okay, so this one here, this line, we have, this is under C, and at the same time under D. So you have C, take note, this is some term, so C plus D. Okay? Then this one here, the square, this one, square, this belongs to D or B bar plus D bar. Okay? And this one here belongs to A plus C. Okay? And this line here, 4 adjacent cells in line, belongs to A plus B bar. And then this one here belongs to B plus what's this? A bar, I mean. This is under A bar plus B plus D. Okay? So that's the intersection of this particular group of cells. So the final equation will be, again, this is product of sum expression. So these are sum terms. Okay? Then the final equation will be A plus C product term times A plus B bar times, this one here is sum term. Then you have A bar plus B plus D, another sum term, times B plus D bar, B bar plus D bar, times C plus D is equal to X. Okay, so that will be our simplified logical equation. Now, what will be our simplified logical circuit equivalent? So we have here some terms which can be represented by an OR gate. So how many OR gates? 1, 2, 3, 4, 5 OR gates. We have 1, 2, 3, 4, 5 OR gates, and then you have inputs A, C, then you have A, B bar, then A bar, B, D, and then you have B bar, D bar, then you have C, D. Okay, and all of these sum terms are being multiplied together using the AND gate. So you have here an AND gate. Okay. this will now be your X. So this one here again is C. This will now be your simplified logical circuit equivalent.